All right, hey everybody. So today we're going to talk about rational expressions. This was a unit that you guys kind of had during quarantine last year, so the whole unit was not really covered super thoroughly, but there are some key things that hopefully you guys picked up last year. If not, they were definitely also taught in Algebra 1, not 1. That's silly. All right, so rational expressions, here we go. Okay, so first we're going to look at simplifying rational expressions. So remember, a rational function is just a function that has an x on the top and on the bottom, or variables of any kind on the top and bottom. They're fractions. All right, so they're fractions that have variables in them. That is basically what a rational is. All right, so basically what we're going to do is we're going to talk about our fraction rules. So for adding and subtracting, just like fractions, you have to make sure that you have a common denominator. All right, so in order to add or subtract, you have to create a common denominator. All right, so adding and subtracting, you must must create a common denominator. All right, so if you have something like this, two fractions, and you want to add them together, you have to make sure the bottoms of these fractions are the same. So that means you're going to have to multiply one fraction by something so that it has the same denominator as the bottom one. All right, and the rule for multiplying is if you're on the same side of an equation, you are allowed to multiply by 1. And so when we have fractions like this, we do it by multiplying by the same thing on top and bottom. All right, so if I want this first term to have a c on the bottom, I have to multiply top and bottom by c. What is happening? Oh, there it goes. It just took a second. Cool. All right, well, the other fraction has a b in the bottom, so we need to multiply top and bottom on this side by b over b. All right, that's going to give us ac on the top, bc on the bottom, plus b times b squared over b times c on the bottom. And now we are allowed to combine to make one giant fraction. So we can't really combine AC and B squared because they're not like terms. So we're just gonna have to write them like that. But we can put them all under the same denominator, which is BC. That is adding and subtracting. So I know I did addition. It works the exact same way if you're subtracting. You need to create your like denominator and then you can combine and simplify. All right, multiplying is probably the easiest one out of all of them because there's nothing special that you have to do when you multiply. You just want to make sure that when you multiply straight across. All right, so you want to multiply numerator times numerator over denominator times denominator. So if we had a over b times b over c, you just multiply straight across. So a times b over b times c. That's it. Multiplying is by far the easiest one. The only thing you have to remember to do when multiplying is if something can be simplified first, you definitely want to make sure that you simplify before doing anything else. All right, the next one is dividing. So this one is pretty similar to multiplying, but there is a step that you have to do before you can just multiply across. All right, because eventually with dividing, you do get to just multiply across. All right, so dividing, you have to KFC first. Now, you guys might not have heard this before, maybe you've never seen this acronym, but it stands for keep, flip, change. You want to keep the first term. All right, so keep the first term. You want to flip the second term. And you want to change the division sign to multiplication. So then you want to change to multiplication. All right, so for example, if you had A over B, go away, divided by B over C, we're going to KFC. We're going to keep the first term. So we keep this first one. So we have A over B. We flip the second term. So it becomes C over B. And then we change to multiplication. Now, just like multiplying our fractions before, you just multiply straight across. So you have A times C over B squared. And that is how you do dividing. Now, this last piece, depending on who your Algebra 2 teacher was last year, you might have heard of complex fractions. Now, complex fractions are nothing super crazy, but they do look scary. We're going to see complex fractions a lot this year. And basically what a complex fraction is when you have a fraction inside of another fraction. All right, so a complex fraction is just a fraction inside of another fraction. They look really scary. All right, good news is they're really not that bad. It basically just becomes a giant division problem. All right, so what a complex fraction is going to look like is much worse than what it actually is. And we're going to tackle complex fractions by rewriting it as a division problem, because ultimately it really is still just dividing. All right, so for instance, if I'm keeping my same fractions, so if I have A over B, come on, over C. That looks really scary, but it's not. It just means I'm taking this piece and I'm dividing it by this piece. So this is my numerator, this is my denominator of my big fraction. So my recommendation is to go ahead, once you've identified your numerator and denominator, rewrite this using a division sign instead of as a giant fraction. It makes it look less terrifying. So you are allowed to rewrite this. Oh my goodness. The pen is going slow. Okay, now that I've broken it. All right, so A over B divided by B over C. Just make sure you don't flip it yet. We are going to flip it when we actually apply the division sign. You're just basically rewriting this in a straight line instead of stacked. So now that it's written with a division sign, it's just like dividing fractions. You keep the first one, you flip the second one, and you change the division to multiplication, and then you multiply straight across, AC over B squared. Okay, so now we're going to do it with actual problems. All right, so we have 4 problems right here. All right, you can see that pesky complex fraction in there. It does look kind of terrifying. All right, but before we get to that, we're going to start with problem number 1, which is a subtraction problem. Okay, so like we said, when we're subtracting, we need to create common denominators. All right, so the first thing that we want to do is we do want to factor these denominators to see if we can kind of simplify it a little bit more than what it is. All right, so the 3x in my first term can't be factored. It is what it is. But the second one, it does look like we can take out a greatest common factor. So I'm going to rewrite 3x squared minus 6x as 3x times x minus 2. right? Because all I did was pull out a 3x and I was left over with the x minus 2 piece. Now this looks a little bit easier. So this first fraction has a 3x. The second fraction has a 3x, so they're matching. The only thing extra that I need that first term to have is an x minus 2 piece. So what I'm going to do to create my common denominator is I'm going to multiply my first fraction by x minus 2 over x minus 2 so that I have a common denominator. So I'm going to multiply by x minus 2 over x minus 2. All right, rewriting that, I have 3 parentheses x minus 2 minus 4x minus 1. All right, now I know I put those parentheses in and we're going to talk about why in a second. All right, all over, and now I have the same denominator, so I can do it all over one fraction. So it's 3x and then x minus 2. Now, the reason I put that minus on the outside and I have that parentheses is because we're subtracting that whole piece. So what we really need to do is take that minus sign and we need to distribute it into our parentheses. Okay, so that's going to give me, and now I'm also going to go ahead and distribute that 3 into the parentheses with the x minus 2. So I'm going to get 3x minus 6 minus 4x plus 1 because I'm distributing that negative. All right, all over 3x x minus 2. Right, so I'm keeping my denominator factored because I expanded the top because I want to combine like terms. So I want to try and see if I can combine some stuff in the numerator, but I want to keep my denominator factored. So I don't want to go ahead and expand that because then it's just going to make my problem look worse. All right, so the last thing that I'm going to do for this problem is I'm going to go ahead and I'm going to combine the like terms in the numerator of my problem. All right, so I can combine 3x with minus 4x to get negative x. And I can combine negative 6 with positive 1 to get negative 5. And that's all over 3x x minus 2. And that's as simplified as it can go. Now, if you want to GCF the negative out from the numerator, you can. Some people like to do that, but I'm totally fine with you leaving it just like this. All right, and that's our problem. All right, so that is simplified and we are done. All right, moving on to number 2. So this is the division problem. All right, so actually I have 2 division problems up here. So I'm actually not gonna do number 2. I'm gonna do number 3 instead because I kind of wrote over in number 2 anyways. So I'm just gonna jump to number 3. They're the same problem. Okay, I was about to say they look like the same problem. They are the same problem. All right, so I'm going to just ignore number 2, like I said, and I'm going to jump to number 3. Okay, now this is a division problem, so we are going to do that keep, flip, change thing. But before we do that, I'm actually going to factor first. I always think it's a good idea to factor first. So with number 3, I need to factor my numerator. So I have n squared plus 5n minus 36. I want 2 numbers that multiply to negative 36 and add to 5. All right, so I can do, oops, where'd that go? There we go. So over on the side, I can go ahead and make my box if that is what makes me comfortable. So n squared minus 36. All right, so 2 numbers that multiply to negative 36 and add to 5. All right, so my 2 numbers, the ones I'm thinking of are 9 and oh my God, 9 and 4, sorry. All right, so 9 and 4, all right, and the 5 is positive, so that means I want the 9 to be positive. So 9n and then a minus 4n, right? Because 9 times 4 is negative 30, or negative 4 is negative 36, and 9 plus negative 4 is positive 5. Cool, so then I just do my box. All right, so over here, I can rewrite my numerator as n plus 9 times n minus 4 all over. All right, now my denominator 5n plus 10 looks like I can take out a greatest common factor of 5 and that leaves me with n plus 2. All right, I'm going to leave it as a division sign. All right, so 4 can't do anything, but it does look like I can factor out a 4 from my denominator right there. So 4, so n plus 2. Awesome. Now, at this point, if you would like to simplify, you can. There is something that is kind of obvious, I guess, to simplify. We have a 4 over 4. We can simplify that to 1 over 1, because 4 divided by 4 simplifies to 1 over 1. All right, and now at this point, I'm going to go ahead and I'm going to keep the first. So I'm going to now KFC, keep, flip, change. All right, so I have n plus 9 times n minus 4 all over 5 times n plus 2. All right, and then flip, so n plus 2 over 1. All right, don't forget the 1. Sometimes accidents happen and people forget the 1 when we're flipping. Don't do it. All right, now we can kind of what's called cross simplifying. All right, we're not cross multiplying, but we can simplify. So if you have something on the top and on the bottom, you can kind of simplify it out, because just like with the 4 over 4, it's going to simplify to 1. So I have an n plus 2 on the top and an n plus 2 on the bottom. So I can go ahead and I can simplify that. All right, and there's nothing else that I have the same on top and bottom, so it looks like that's as simplified as I can go. So it looks like my final answer is going to be n plus 9, n minus 4, all over 5 times 1, which is 5. And that is my final answer. All right, last but not least, we have problem number 5, which is our complex fraction problem. So I got to delete that a little bit. All right, so what I'm going to do is, before I do anything else, I'm going to rewrite this as a fraction problem, or sorry, a division problem. I want to get it out of this fraction form. So this is my numerator, this is my denominator. All right, and I'm just going to have like a little division sign in between them, right? So here we go. So this is 4m minus 36 over 5 divided by m squared minus 15m plus 54 all over 9m minus 54. Okay, so just like my division problem, I am now going to factor. All right, so next up, factoring. So take out the 4. All right, and then staying division, so I'm not going to flip it yet. All right, so I want two numbers that multiply to 54 and add to negative 15. I believe that is 6 and 9. All right, so you can go ahead and do your factor box if you want. I'm just going to go ahead and write it. All right, so that's how I end up factoring that top piece. And then the bottom piece becomes just 9 and then m minus 6. Okay, so before I flip, I do notice that on my second term, I have an m minus 6 over m minus 6. I'm going to go ahead and simplify before I flip. Remember, you can only do that at this stage if it's in the same term. So if I can't do my cross simplifying yet, I have to make sure it's multiplication before I do the cross simplifying. But since this is in the same fraction, I can go ahead and simplify. All right, now I am going to do my keep, flip, change. All right, so I keep the first one, 4m minus 9 over 5. I change it to multiplication and I flip my second, m minus 9. Now, some people at this stage do a very wrong step. Please don't be this person. You cannot simplify the 9 over 9 in this one fraction. So I'm talking about right up in here. You cannot cross those off. That is wrong. You can only cross off things that are being multiplied on the top and the bottom. The minus 9 in the denominator is connected with the m by that subtraction sign. So for those of you that thought you could cross it off, you are wrong. I see it all the time. You cannot do that. Okay, But what we can do is we notice that we have an m-9 binomial on the first term, and we have an m-9 on the bottom of our second term, and those we are allowed to simplify because we have one on the top and one on the bottom, and it's multiplication. All right, it doesn't look like there's anything else that I can simplify, so I'm just going to multiply straight across with what I have left, which is 4 times 9, so 36. All right, and then on the bottom, I just have a 5. All right, so we have 36 over 5. There we go. All right, so that is it for simplifying rational functions or rational expressions. Our next video is going to be how to solve a rational equation. All right, until next time, bye.